Hey guys, today is Wednesday, May 13th, 2020, and today we're going to be starting to get into our first sort of main topic in astronomy. Yesterday you got a little introduction to the unit and to the scale of items in our solar system mostly, and some ideas about things outside our own solar system as well. So remember, we're shooting for this unit about this whole idea of whether Earth is unique or not, and what life requires from an astronomy basis to be successful. So we're going to start on our first kind of main topic in that, and if you looked at the Padlet, you may have already seen a little bit about this. So for today, you can see under our activities, we're going to be focusing on something called the habitable zone. It's also called the Goldilocks zone. So think like the Goldilocks and the Three Bears. So we're going to talk a little bit about what the habitable zone is, and you guys are going to be exploring a graph that kind of represents the parameters of the habitable zone in our solar system, and then you'll be working with the graph in our activity for the day. I've also posted a habitable zone video for you guys to watch as well. So once you hear my little spiel about it, check out the habitable zone video clip. It's real short. It's really good. I really like it. This is the first time I'm using it, so I was really excited to be able to share this with you guys. And then there's a little reading, on the habitable zone for you guys to kind of work on a little bit for homework, just to give you some background information, or if you're working on the lab and you need a little bit more help as far as like what the habitable zone is and the requirements, check out the reading. It's got a lot of good stuff in there. Okay, so let's talk about the habitable zone. Okay, so the habitable zone is this area around a star where water can exist in all three states, as a solid, liquid, or a gas. Okay, so obviously Earth is within the habitable zone. In the lab today, you're going to try to find out if there are any other planets that fall into our habitable zone. What are they? Where are they in the habitable zone? That type of thing. So essentially what scientists are doing right now is if they discover a new planet, which they're using like the Kepler project and some of the other telescopes to discover new planets, the first thing that they're really looking for is if the planet is in the habitable zone. And it doesn't necessarily just have to be a planet. It could be a moon as well. So like if we find a planet, it's in the habitable zone, but we look at the planet itself and it's no good for life, but maybe it has a moon that might support life, that kind of throws things in the mix as well. So we're looking for not just planets, but also at moons as well. So we're looking to see if these planets are found in the habitable zone. If it's too close to a star, the water will just boil away. If it's too far away, it will just be in a solid state. And we know ice isn't really all that great for supporting life. So we're looking for all three states of matter. And it's in a particular temperature region, essentially, to the sun. And that's kind of where the Goldilocks principle comes in. It's not too hot, it's not too cold, it's just right. And we actually use this Goldilocks principle pretty frequently in science, but also in a lot of other aspects, which you may have seen on the Padlet site, where you're looking for a certain range of kind of the middle ground. You don't want anything extreme, which is what we're looking for with this search for planets and potential search for life as well. Okay, so let's talk a little bit about this activity that you guys are going to be looking at. So you are going to be looking at a version of this graph that you see here. This is a pretty famous graph. So when you're taking a look at this, you can see it's color coded, and I'm going to show you guys what you're going to see in a few moments. So basically, you want your planet that you are studying or examining to fall within the green zone. Okay, you don't want to be too hot or too cold, because of course then it's not going to support water and of course life. And when you're looking at the graph, it's looking at two pieces of data to help us decide where the habitable zone lies. We're looking at the temperature of the star, Okay, so, and it kind of makes sense. If you're looking at a star that's 7,000 degrees Kelvin, the habitable zone is going to be farther out. If you're looking at a star that's only 3,000, the habitable zone is going to be much closer to the star. So that's why on the bottom we have the distance. Remember, that's in AUs, that's the astronomical unit. And if you remember from yesterday, 1 AU is at the same distance as Earth to the sun. Okay. So like 3 AUs would be 3 times that distance, 4, and so forth. Okay, so let me show you what it looks like in the lab. Okay, I'm actually going to switch my screen so I can kind of animate this a little bit better. So you guys can see how this graph was actually made, because you're not making the graph, but you're adding to the graph. So I'm just going to switch over actually to PowerPoint here. So just bear with me for a second. There we go. Okay, so this is the basic setup. It's the same as what you guys just saw in the one that I, got offline. We've got the temperature of the star over here, and we've got the distance from the sun. Okay, and we have a couple of data sets that I use to kind of make the edge of the habitable zone graph. So data set number 1, and you can see here again, this is the stellar temperature, and this is the distance from the star. You can see I've plotted them. Okay, so the distance from the star is 2 AUs, so that will coordinate with a 3,000 degree temperature star. Okay, if the star is 4,000 degrees, the habitable zone would begin at 0.12, 5,000, 0.4, and 6,000, you can see 0.8. And then you just connect them all together, and that's the edge of the habitable zone. So this is kind of like the closest a planet could possibly exist in order to facilitate the presence of water in all 3 states. The second data set, the other side of the graph, is the other edge of the habitable zone. So I would say the farthest distance a planet could exist and still be in the habitable zone for any given star. And again, I'm just going to graph it for you real quick. So we've got at 3,000, it's 0.05 AUs. Then 0.3 for 4,000, and then 1 for 5,000, and 2 AUs for 6,000. And again, we'll connect the dots. So basically, once we study a planet and study its host star, we're looking at, does that planet, we can measure how far away it is. Does it fall into that nice habitable zone? Okay, and I'm just going to color code too hot, too cold, just right. Okay, so we're always going for green. Okay, so what you guys are going to be doing is I've given you a list of planets, and you'll see this when you open up the Google slide presentation in Classroom, that you are going to graph. Okay, so you're going to graph the location of these different objects. Okay, and you're basically going to click and drag. So there's going to be like a little symbol, and you just click it and drag it to where it belongs on the graph. Okay, and then essentially once you've moved these items onto the graph, then you're going to answer a few questions and figure out which planets are in, which planets are out. Most of them are in our own solar system. These last 2, the Kepler and the Gliese, these guys are extrasolar planets, so meaning they're outside of our own solar system. So they're orbiting, another star. They're not orbiting the sun. Okay, and it gives you a little bit of information about the stars, their spectral class, which is like their size and their brightness. You can see the sun is a G class, and these guys are K and M. So that's what you're looking at here. Okay, so you'll check those guys out and see if they fall into the habitable zone. Kind of explore this idea of the habitable zone a little bit more in depth today. You're going to answer those questions on the second slide, and then you'll turn the assignment in tomorrow or later today. Sorry, and then the next 2 days, so Thursday and Friday, we're going to be looking at the stars themselves. So you're going to learn more about these spectral classes and the temperatures and the colors and all different kinds of things. We'll focus on our star first, and then we'll focus on some of the other stars as well. Okay, so just like usual, as you're working, if you have any questions, please let me know. My office hours, actually that should be changed, but that's okay. Today, so for Wednesday, it should be from 10 to 11 for Wednesdays. Hey, and so I'll be in there if you guys need help with the habitable zone or with the graph in any respect, just let me know. I'll be happy to help you guys out. And even if you can't make it to office hours, send me an email, send me a message in Google Classroom. I'll be happy to help you guys out with this. All right, guys, I hope you have a great day, and I will see you in class tomorrow for stars.